This is a video about ratios and proportions, kind of an introduction or a review to ratios and proportions. So let's start with the idea of ratios. Now, I'm going to give you the definition of a ratio. That's where I'm going to start, and then I'll give you some examples. Definitions in math become really important because in math there's so many words that have special meanings. The word area has a very special meaning, and it's totally different than volume, and it's totally different than perimeter. If I read a question about area and I'm not sure what area is, it's going to be really hard for me to solve that problem. So likewise, if I read a question that's got ratios, but I'm not sure what a ratio is, it's going to be really hard to solve that problem. So whenever you come across a math word, a new word in math, take some time to figure out what the meaning of that is, and I'd suggest even writing it down, making a little glossary or a dictionary for yourself with math words. So what is a ratio? A ratio is a comparison of two things. Now, I've left a space there on purpose. We're going to come back to that. A comparison of two things. So, here's a common example. I can compare all sorts of things. I can compare inches to feet. I can compare, well, let's do that, inches to feet. So, if I look at the comparison of inches compared to feet, then I would say that, well, the comparison is that there's 12 inches compares to 1 foot. There's a ratio. 12 inches compares to 1 foot. I'm comparing two things. I'm comparing inches to feet. Notice I'm comparing. There's my statement compared to right there. Now, when I wrote down the ratio over here, instead of writing down the words compared to, I wrote this symbol. We'll call that a colon. It is a colon. That's one way that I can separate things, the things I'm comparing in a ratio. So that ratio would be 12 inches compared to 1 foot. There's different ways I can write ratios. A colon is one way. I could also write with a word, to 1 foot, 12 inches to 1 foot. And now you might notice that when I use the word to, I'm really using it as a short form for this bigger expression, compared to. So I could even read it that way, 12 inches compared to 1 foot. Here's another way to write out a ratio, 12 inches compared to 1 foot. And that looks like a fraction. But in this case, I'm writing it as a ratio. Now, if all you saw on a page was 12 inches over 1 foot, the clue that this is a ratio is I'm comparing two different things. You remember that a fraction, let's say 12 over 1 here is a fraction. When we're talking about fractions, the bottom is the number of pieces that the whole is broken into, and the top is the number of those pieces that I have. So top and bottom are talking about the same thing. So if this, let me give a more, I chose that because it matched the one, but if I had like 1 over 12, that means that my whole thing is broken into 12 pieces and I have one of those. So if it's a pizza broken into 12 pieces, I have one piece out of the 12. Top and bottom in a fraction are both talking about the same thing. Bottom's talking about how many pieces in a whole, top's how many pieces I have. A ratio, though, is comparing two different things. We're not talking about pieces and wholes. It's 12 inches compares to 1 foot. There's an example of a ratio. We could also compare, when I'm making frozen orange juice from a can in the fridge, this is the ratio that I use. When I'm making that frozen orange juice, the ratio of orange juice compared to water is 1 can of frozen orange juice compares to 3 cans of water. So I could have written 1 can of orange juice compares to 3 cans of water, or 1 can of orange juice compares to 3 cans of water. In this case, it's cans orange juice, cans water. This is not a fraction because the bottom's not talking about how many parts make a whole and the top's saying how many parts of those do I have. No, this is comparing two different things. They're both cans, but the top's cans of orange juice, bottom is cans of water. Now, remember I left this blank. I left that blank because I want to be able to write in here now that a ratio is a comparison of two or more things. Let me show you what I mean. Two or more things. In our family, we make lemonade, and when we make lemonade, we make it from water. We mix water and lemon juice, and that's going to be really sour if we don't add sugar. Okay, I'm winging this recipe, but we use a ratio of about 6 cups of water compares to 1 cup of lemon juice compares to a 1/4 cup of sugar. So there's a ratio with 3 things in it. It's a ratio of 6 to 1 to 1/4. Now notice that ratio has a fraction in it. That's a 1/4 of a cup. 1 cup broken into 4 parts give me one of those 4 parts. So the ratio here has got 3 parts in it. So what is a ratio? A ratio is a comparison of 2 or more things. Most of the ratios we'll see at ESU will have 2 things in them. Now, the topic of ratios is connected really closely with the topic of proportions. And you might have heard the word proportional. Proportional. Best example I can think of or an easy one with thinking about proportional is if I take an image from the internet and stretch or shrink it. If I stretch or shrink it in a way that is proportional, then when I'm finished, the image will look the same, bigger or smaller, but it won't be stretched or squished. It will still have the same proportions. So here's a picture of a AMC Pacer. Now, this image on the screen that we're looking at right here, in red pen, I'm saying it's 4 boxes high. Let's call them units. They're not inches or centimeters. So 4 units high, 7 inches wide, length and width, 4 and 7. Now, if I take this thing and stretch it by grabbing that handle, what I've done is I have doubled the height. So instead of the height just being 4, it's now 8. If I've doubled the height, then I've also doubled the width. So the width has gone up to 14 units now. So the Pacer still looks the same. It's bigger than it was before, but I haven't squished it or stretched it in any way because whatever I did to the width, which was double it, I also did to the length. I doubled it as well. So we could say it's proportional. The images are proportional. You've probably heard people say, boy, that's out of proportion. That's when I've maybe taken a picture like this and stretched the length by 2, but I did not stretch the width. And if I do that, I end up with one crazy looking thing. And I tried it here on Google Jamboard and it won't let me. It'll only let me make proportional changes. So that's where the word proportion comes from in regular use. What does a proportion look like in math? Well, a proportion, here's the definition. Let me get the pen back. A proportion is a statement that 2 ratios, so you can see this is related to ratios. 2 ratios are equal to each other. So this is where we're going to find it really useful to write our ratios as something over another. So in this case, the beginning ratio of the Pacer was height of 4 compared to a length of 7. So what I'm doing right here with the H over the L is making it clear what I'm comparing. I'm comparing the height to the length. So that means that the top of this ratio must be talking about height, bottom of this ratio must be talking about length. Let's carry on. That's the first ratio. A proportion is a statement that 2 ratios are equal. What's the second ratio? Well, the second ratio came from the green numbers. After I stretched it, the height was now 8 and the length was now 14. That's the green ratio coming from a stretched height of 8 and a stretched length of 14. So I've written height over length because that's the pattern that I set out at the beginning. Now, it's not a proportion yet. I definitely have two ratios, but this has to be true. And I know that's true. So I'm going to put the equal sign here. Now I have a proportion. A proportion is a statement that two ratios are equal. Here's ratio number 1. Here's ratio number 2. The ratios are equal. That's a proportion. And proportions are super useful tools for solving problems. And we're going to talk about that tool a little bit in the next video. So there's an introduction to ratios and proportions. Ratios are a comparison of two or more things, and proportions, I like to say, are built out of ratios. Proportions are statements that two ratios are equal. And the ratios and proportions, you notice here I've got ratios comparing two things, and those two ratios are equal. All right, hang in there for the next video.